Hello, everybody. So this was my final art credit in my last year of school, and I decided to build a guitar based off of the fact that I wanted to build a. This is a certain type of guitar. It's called a headless guitar. You can see that little black piece at the top is where the strings go in, and it clamps down on top of those so that you can tune them. But I wanted a headless guitar. I think that they look cool, and I think that some of the ergonomics would help with how I play guitar, and it also kind of is just a little bit easier to move around and play. I am in a band and I take classes, and it's kind of a little annoying to have this big clunky guitar that you have to take places for if you're playing gigs or anything. But as you can see, I'm drilling out the holes to connect the neck to the body of the guitar. And some guitars have a fixed neck, which means that the neck is directly connected to the body without screws or anything. This is one that has a screw-on neck, so I could change it at any time if I pleased. But you can see the body that there's this area at the bottom, and that's where the tuners go, so that you can actually reach your fingers in and turn the bottom, which is where the knob is to change the tuning. And here I'm running in the screws, which unfortunately ran through the front of the fretboard and caused a hole which I had to fix later. But that wasn't too big of a deal. And you can see the big pocket there on the right is where all the electronics go. And at first I bought everything off Amazon. I had like this wiring kit that was all pre-wired and everything. And all the solders were kind of bad, and I used it for a little bit, and it didn't sound great. I also had these cheaper pickups that I didn't really like. So I went out of my way and spent some more money on Facebook Marketplace and bought pickups from a very nice guy that were a little bit nicer and sounded better. Here's where I saw that I ran through the front of the fretboard. And eventually, through trying to fix some of the grounding problems, I broke the pre-wired set that I had and ordered new ones off Amazon, potentiometers, a switch, and an output jack. That is what all goes into the electronics of a guitar. Now, some guitars have active pickups which require batteries to run them, but the pickups that I have are completely, they run off just the power that they get from the output jack. So, eventually, after rewiring the guitar, which you'll see at the end of the video, I thought that I did a pretty okay job. Everything sounds good. There's still a little bit of problems with grounding, which can kind of cause the guitar to buzz because it will pick up signals from electrical objects around you. Like if you're facing a computer or your amplifier, it can pick up some of the electrical signals because pickups actually use magnets to pick up the vibration of the string and turn it into a frequency that is sent through your cable into your amplifier, which amplifies it and plays it aloud through basically a speaker. And I didn't know how to wire everything, so that's why I bought the pre-wired kit off Amazon. And after buying all my stuff, I watched a couple videos and went and soldered everything together, and it sounds better and plays better. You have to wire a resistor onto the tone pot, which what a tone potentiometer does is basically it's like a equalizer for the upper end of frequencies. So when you turn the knob up, those frequencies get louder, and down it gets quieter. If you think of like a little straight line and the very right end goes down and up whenever you turn the knob. And what the volume knob does, it doesn't actually change volume. It more adjusts the strength of the signal coming from your guitar to the cable. So something interesting that does is if you have a distortion pedal or a distortion channel on your amp, it actually won't be very distorted unless you have your volume knob turned up all the way or most of the way, which makes the signal stronger and obviously lets it be more distorted. And the way that distortion works in pedals is when the signal is ran through the pedal, it's like a sine wave. And usually sine waves are smooth, but there's a type of sine wave called a saw wave, which is more of a jagged wave. And the way that they found distortion was running it through an amplifier, and when they turned it up, the frequencies would peak to a certain point and chop off the top, so not making it round and making it more of a square wave or a saw wave, which sounds more distorted than a regular smooth sine wave. And something interesting that I think is interesting is that is why they invented pedals, which did that specifically so that you didn't have to turn your amp up super loud and cause damage or, well, noise complaints, because amplifiers do get very loud. And the first pedal that was made specifically for distortion was called a fuzz pedal, because distortion can sound kind of fuzzy depending on how it's done. But I think it's cool that, these people discovered that you can run it through anything, actually, as long as you can turn the volume knob or the gain knob up and cause those frequencies to clip and turn into a more jagged wave, which causes distortion and, fuzz, and it sounds pretty good. People have been using it for 60 years, playing guitar live with pedals. And I thought it was sort of interesting how they discovered that. Another interesting thing about pickups is the way that they're wired, or at least I think. So the way that a pickup works is you take the ground wire and you solder it to a little tab on the bottom of a switch. And there makes some that are 3 positions and some that are 5 positions. The one in this guitar is a 3-position switch. And you take the ground, you solder it to one of the tabs on the bottom, and then there's 2 little black wires, and you solder those to little tabs that are on the outside. So there's like 4 tabs, 2 in the middle, 1's on the outside, and that's the ground of the case. So you solder the grounds to the case, and then the 2 wires to the little tabs on the outside. And when you flip that switch, it controls which pickup it is using, and there's like different pickup positions are meant for different things. Like the bridge pickup, which is the pickup closest to the bottom of the guitar, or the bridge, is mostly used for like power chord stuff, which isn't like full chords like you'd hear in maybe a pop song. It's more of like a rock thing. And the neck pickup, which is the one closest to the neck, is used for stuff like chords, open chords and bar chords, more stuff that you'd hear in pop music and maybe jazz. So they make different types of pickups too. There's single coils and humbuckers, which have 2 pickups. There's the slug coil and the screw coil. There's 2 different coils. The slug coil has a wider frequency range, so it can pick up lower end frequencies like your lower E, A, and D strings. And there's the screw side, which has smaller pickup frequency, I suppose. And it will pick up your higher strings, like your high E and B and G. And one thing that some of the more expensive guitars do is when you have the switch position in the middle, it will use both outside, both slug pickups or both screw pickups, and kind of give you a different sound. It'll use 1 slug and 1 screw from each pickup, because the slug pickup will still pick up lower frequencies like your low or your higher frequencies, but it just won't sound as good. That's why you move your pickup switch from its bridge position to the neck position, because it will pick up the lower, higher frequencies better, making your chords sound warmer, whereas that doesn't really matter in like metal stuff where you're just playing the power chords and it doesn't have any like emotion in the chord, major or minor or diminished. And that was just one of the things that I found interesting about actually learning how to build a guitar, was the different ways that you can use pickups and use what the pickups have. On humbuckers, there's 2 special wires that come out, and they can control something called the split coil, which is both coils individually. So you can wire up to have it act like a single coil pickup, like you'd see in like a Stratocaster guitar that has 2 single coil pickups and maybe a humbucker, maybe 3 single coil pickups. So another thing that you need to learn when you are building a guitar is the different like terminology of the action of the guitar, which is how high the strings are away from the fretboard, the intonation, and how the nut is made, and how your bridge is positioned, the length from the nut, which is there's a little piece at the top of the guitar. It can be made out of bone or plastic or several different things, maybe graphite. But there's a distance between the nut and the bridge, and it has to be a certain length. Like on this guitar, it's 25.5 inches. So that when you put the string on, the halfway point is where your 12th fret would be, because that's how you intonate the guitar. And what intonation means is how accurate your pitch is to the fret that you're playing on. So like you can be playing the 12th fret, which should be an E note. It's exactly 1 octave higher than your open string, and it can be several cents off, which is it's not a lot, but it's definitely noticeable if all the other strings aren't tuned the same way. It can make your chord sound kind of sour and bad. But there's also little screws that you can adjust to try and fix this. So if you're playing your 12th fret and the note is sharp, then you can move it's called a saddle. You can move it farther away from the nut, which makes the string longer and will pull your harmonic back. And it should make the intonation better, which is the note that you're playing. The problem that I had with this first time that I built the guitar, before I had to take things apart and change some things, is that my 12th fret would always be sharp. It didn't matter how far back the saddle was or anything, and that was because my action was too high. So when you would push down on the fret, it would actually stretch the string enough to make it sharp, and then it would still be a problem no matter how far back you push your saddle, which it was kind of a problem that I didn't really think about until I looked, and I was like, oh, well, that's actually a pretty big distance away. But if your action is too low, it can also cause the frets to buzz, which sounds really bad when you're playing. So you have to it's a really tedious process of adjusting your action screws and adjusting the intonation screw, moving the saddle back and forth, and your guitar will go out of tune a bunch, and you have to retune it and then move it again because you have maybe a fret buzz on the 18th fret, or it won't play on the 18th fret, and it'll play the next fret up because it might be a little higher than the fret before it. So you have to move up the saddles and make it so it'll go over that fret, which was it wasn't a big problem, but it caused some issues when I was first putting this guitar together. And it was really aggravating because I wanted to, take it and play at my lessons or with my band, and I would always have these problems that my guitar wouldn't quite sound exactly right, and it would kind of clash with everybody else's guitar, which was well enough intonated that you couldn't notice it. So even after getting most of the electronics installed and pickups, I still had a lot of wiring and soldering that I had to achieve, and drilling out spots for the input jack and potentiometers. And another thing that I had to do was cut out some of the sidewalls to fit in the bridge, which was a little bit of a struggle because I later had to go in and cut out below it to make it lower to fix some of the action height. And here you can see that this is where I got it in. This was before I had to lower it down. But it fits in, and then once I load it, it plays very well. Here's some pictures of the soldering that I did, and, well, actually this was pre-soldered, but I did do some soldering, and this was the first string that I put on the guitar, and once everything was done, it was playable. I took it and played at a few of my band classes, and it plays very well. I was very happy with how it came out, and I'm glad to have it.